You're probably looking at this image right here and thinking, Miss Price, these things haven't been used since the 1990s. Well, that's not quite true, and you're going to find out why in this video. Firstly, scanners are just simply an input device. So that means we do use this to put data into the computer. The beauty of scanners is they can take a hard copy, which could be a photo, like maybe a photo of your mum or dad when you was a baby, when they were babies rather, and digital cameras weren't around, phone cameras weren't around. So it's all you have is simply this photo, and it could be damaged over time, maybe it's faded. Well, the beauty of it is we can actually take that photo and we can make it into a digital copy. With that, you can edit it, so you can use it in Photoshop, you can edit the picture, you can store it, you can email it, you can upload it onto the internet, onto social media, and you can do the same with any document. So the beauty of these scanners is that we can actually take something before the digital age that we're in right now, and we can make it part of our digital age. So there are two types of scanners. So we're going to look at firstly the 2D scanner. Here are the steps to scanning. It's really simple. You raise the cover, which is here. Place the document on the glass. Then a white light will come over this glass right here, where the scanner head will move and produce an image. Then that image will fall into a charge couple device, CCD. If you've ever used a scanner, you probably not really thought of anything more than what happens. They're such a small device and such a simple technology. The charge couple device. So I'll bring these up here. Now, what happens is that the movement of the electrical charge will basically convert your hard copy into pixels. This is what happens. So you've got the lamp here, which is the scanner head, and it will move across the glass plate, so across here. So there's the original document, and then that light and that image is reflected onto these mirrors, which go through the lens here, so it almost takes a picture of your picture, I suppose. Then you've got your charge couple right here, your charge couple device right here, and then your image becomes made up of thousands of light sensitive elements, which are basically pixels. So what happens to your image that will go from this original document here, bounces off these mirrors through this lens, and then becomes an imprint of pixels, is your image will become a representation of what the original document is. So now you will have the hard copy, and as if by magic, you've also got a soft copy. Optical character recognition, or OCR. This is amazing, and most modern computers are now equipped with this because it's so useful. It's become part of our everyday lives. So the scanned text can be converted into text file format and edited into word processing software. You can take your textbook, you can place it on an OCR scanner, you can select an area of text, and then that text can be saved as a fully editable word processed document. This obviously has caused problems in some places, like at one time it did contribute to crime, but of course it can also be useful for you doing your studying and your research. So we've got our 2D scanners. Have you ever thought of 3D scanners? Well, they do exist. Here's an example of a 3D scanner. You're probably sitting here thinking, well, this is actually no different to what I can do on my phone. Well, you're completely wrong. So you can scan solid objects and output a 3D image onto your screen. Two-dimensional objects, as you know from your maths classes, have a y-axis which goes down and an x-axis which goes across. To make something 3D, you need to add your z coordinates. So they've gone one step further from being able to scan something that's two-dimensional to be able to, like, let's add these z coordinates. The images can be used in CAD or 3D printing. So if you can 2D print, why not be able to 3D print? How do they work? Now, they do use several technologies. As you see in the previous picture, they're using lasers to pinpoint. They use white lights to scan, and then they use magnetic resonance to actually form the shapes. And I will discuss more how they will actually form these shapes. Here's an example of a CT scan where the technologies are used. Right, so here we go. Application of 2D scanners. I've discussed with you what the scanners are, but where are they used? And you may not have ever thought about it, but I have, because I fly several times a year. But they are used in airports in several countries. When I take my passport to the gate, I scan it on the flatbed scanner, as you can see right here. What happens after that? Have you ever thought about that? So, it scans my passport and my information will appear somewhere else. Something has to happen after that. If I could just take my passport and just scan it on a flatbed scanner, well then I could be using a fake passport, I could be using somebody else's passport. So there needs to be some validation process here. And this is something that the application of 2D scanners has. So we've got the 2D scanning technology, and it will of course use the OCR technology. Intelligent OCR, not just for your computer but also for checking passports. Here you've got your image and here you've got your text. Now, what do computers read? I hope you said ones and zeros. Because OCR technology is so intelligent, it can manipulate the data in so many different ways. It reviews the image from the database. So what it does is it's going to take the text and it's going to sort it into the fields and it's going to compare that information to the database. And this all happens within a minute. How long does it take you to actually scan your passport? Well, thankfully, because I've got a new passport, I'm out of those gates within less than a minute. Which is amazing. So it does all that in less than a minute. Now, obviously, your information is going to be stored somewhere. And it's going to store it as, well, a bunch of ones and zeros. So when it actually captures that data, it's converting all your text into a bunch of ones and zeros. But not your image. So don't think that your image is going to be stored on a database into the computer like this. Your image is simply stored as a JPEG. But the computer is not a human being. So the computer cannot just look at that image and compare it and say, oh yes, that's Jane Doe, it looks exactly like her. Well, there's many people that do look alike. So when your face is being scanned by the facial recognition system, an image is taken of you compared to the one on your passport. Now, you're probably thinking, well, for example, men can change their faces. They can grow moustaches, they can grow beards. Women can dye their hair. We can have our eyebrows shaped. You know, people change. So what the facial recognition system does is that it measures the distance between the eyes. The width of your nose, the shape of your cheekbones, the length of your jawline, the shape of your eyebrows. Because those things are not going to change.
Appearing at the end of the 1970s, laser triangulation technology paved the way for new technology capable of 3D scanning objects. Usually reserved for industrialists, this tool has gradually evolved over time, allowing us to easily find affordable 3D scanners to use for ourselves. These range from a 3D scanner created by MakerBot to new scanners that can scan underwater. Number 1. The XYZ Printing Scanner 2.0. The Taiwanese 3D printer manufacturer of 3D printers, XYZ Printing, launched its first 3D scanner back in 2015. Now a newer version has just been launched, the 3D Scanner 2.0. It is relatively small and light, with its 238 grams, offering the user a great mobility and ease of use. It includes 4 different scanning modes, allowing you to scan objects, a whole body, a head, or a face. The maximum size of scanning is 100 by 100 by 200 centimeters and has a resolution ranging from 1 to 2.5 millimeters. Number 2. Cyclops 3D Scanner by BQ. BQ Cyclops Scanner is the only open source 3D scanner in our ranking. The 3D laser scanner comes with the Horse software, and all the information on its design, software, and electronic components are all free online. The Cyclops, based on laser triangulation technology, can scan objects in under 8 minutes and has a scan area of 200 by 200 by 205 millimeters. BQ's direct sale channel have been out of stock since 2016. However, the scanner is still available online and through resellers like Amazon. It contains a step-by-step guide on how to mount the 3D scanner in less than an hour. BQ also still have a support channel if you have any questions. Number 3. The Structure Sensor. This scanner allows you to attach it directly to your Apple tablet. After downloading the associated application, you will be able to scan 3D models autonomously for up to 4 hours. With dimensions of 119.2 by 28 by 29 millimeters and a weight of 0.21 pounds, or 95 grams. It's one of the world's smallest 3D scanners. Its precision can reach up to 0.5 millimeters. This little 3D scanner enables 3D scanning, indoor mapping, and mixed reality gaming directly on your Apple tablet. Number 4. Sense 3D Scanner for 3D Systems. 3D Systems were the first company to enter the 3D printing market, creating stereolithography 3D printers in the late 1980s. In the present, they have released the Sense 3D Scanner. This is one of the most popular low-cost scanners on the market today and can scan large columns ranging from 200 by 200 by 200 millimeters to 2 cubic meters. It measures just 178 by 129 by 330 millimeters and has an accuracy of 0.90 millimeters and has a color resolution of 1920 by 1080 pixels for texture-color-texture mapping. Operating with structured light technology, it comes with 3D Sense software that includes a simplified interface and interesting post-processing tools. Number 5. Matterform V2 3D Scanner. This 3D scanner was designed by the Canadian company Matterform. With 2 lasers, the Matterform V2 allows the scanning of objects up to the maximum height of 9.8 inches or 25 centimeters and a diameter of 7 inches or 18 centimeters with a precision of 0.1 millimeters. It is compatible with all 3D printers and can be used by manufacturers for applications ranging from art to design and training. Number 6. Davinci 1.0 Pro 3-in-1 from XYZ Printing. The Davinci 1.0 Pro 3-in-1 manufactured by XYZ Printing is not a traditional 3D scanner. As the name implies, it's a hybrid machine that allows you to scan, print, and engrave all in one. The machine therefore integrates a scanner module that works by laser triangulation. If you look at its specifications, the scanner offers an accuracy of 0.25 mm and a resolution of 2 140 dots per centimeter squared. The Davinci 1.0 Pro 3-in-1 is a machine that will allow you to cover the entire process of creation, from design to manufacture. Number 7. Einscan SE from Shining 3D. The first 3D scanner from the Chinese company Shining 3D arrived on the market thanks to a Kickstarter campaign. From there on, the range has evolved and the manufacturer offers 3D scanners adapted to all needs. The Einscan SE is an evolution of the S. With a new design and improved performance, it's even more suitable for beginners, the education sector, and office 3D printing. Like its predecessor, the Einscan SE uses structural light technology with white and invisible light, which makes it much safer for children. The scanner offers two types of scanning, auto scan and fixed scan. With the first, you place your object to be digitized directly on the turntable. In 2 minutes, the scan digitizes a 360-degree object with an accuracy of 0.1 millimeters. For larger models, 700 by 700 by 700 millimeters, you must use the second method, where you position the piece at the end of the stand, i.e. at the location of the board. Number 8. Rangevision Smart 3D Scanner. This 3D scanner, based on structured light technology, was developed by the Russian manufacturer Rangevision. It is a professional desktop tripod scanner that is ideal for scanning objects between 4 centimeters and 1 meter. On the specification side, it offers an accuracy of 0.1 millimeters and a resolution of 0.12 millimeters. Its near scan surface is 150 by 112 millimeters, while the farthest is 500 by 375 millimeters. Finally, it has 2 cameras and an autofocus that simplifies calibration. It is now available in gray, yellow, and red. Several accessories can be added to the Rangevision Smart as an automatic turntable. Number 9. Next Engine Ultra HD. The American manufacturer Next Engine is at the origin of the Next Engine Ultra HD professional 3D scanner. It is able to scan different textures, but also objects in color. Its near scan surface is 130 by 97 millimeters, and the distance is 343 by 257 millimeters. The Next Engine Ultra HD is based on laser triangulation and offers a maximum resolution of 0.1 millimeters. It can scan 50,000 points per second with a maximum accuracy of 0.13 millimeters. Finally, it can work with or without a tray, thus opening the field of possibilities. Number 10. Structured Light Pro S3 from HP. This professional scanner, based on a structured light technology, is an evolution of the David SLS3, manufactured by the company David Laser Scanner, which was bought in 2016 by the American giant HP. With its price and a 360-degree scan, this scanner has an accuracy of 30 microns or 0.5 millimeters, equivalent to 0.05% of the size of the scanned object. It includes an adjustable metal stand and tripod. It consists of a video projector and a professional HDMI camera. Number 11. Einscan Pro Plus from Shining 3D. The Einscan Pro Plus scanner from the manufacturer Shining 3D was officially introduced at CES 2017. It is a professional manual scanner based on a structured light that can be used without limitations from support, thus increasing the scanning size possible. It offers several modes of scanning: quick hand scan, manual HD scanning, automatic scanning, and free scan. The Einscan Pro Plus offers a resolution of 0.24 millimeters. Number 12. Ireal from Scantech. Ireal is a professional portable and handheld 3D scanner manufactured by Scantech that integrates the company's structured light technology. Scantech specializes in developing, manufacturing, and selling of intelligent visual inspection equipments. The Ireal 3D scanner utilizes the advantages of AR, HD image acquisition, and metrology 3D measurement. It fulfills the demand of 3D modeling texture in non-industrial businesses and brings cost-saving transformations to companies. Moreover, it delivers high-speed scanning at 550,000 measurements, advanced algorithm, and easily captured 3D data in full color. Finally, it has high precision, and it offers a resolution of 0.1 millimeters. Number 13. Evalight from Artec. Evalight is the most affordable version from the professional scanner specialist, Artec. This professional scanner is suitable for scanning complex geometries, such as those of the human body, which is why it is widely used in the medical sector. It uses structured light technology, and although it is not able to scan colors and textures like most of the brand scanners, the evalight does have an accuracy of 0.5 millimeters.